All right, let's look at the last question. That is question 12. It's really a bit complicated diagram which needs to follow very, very closely. In the diagram below, two circles touch each other externally at point P. That's where the circles touch. QPR is a common tangent. Please, we have a tangent there, QPR, to both circles at P. And then EDRC is a tangent. EDRC is a tangent to circle PBFC, to circle PBFC. So it is a tangent to this circle. So this circle has two tangents. This big circle has one tangent. So bear in mind that we may need to use those two tangents. All right, and then angle RCA is y degrees, and then angle DAC is x degrees. Okay, and then we are also given that AB is parallel to BC. AD is parallel to BC. All right, now let's answer the questions. We are asked to name with reasons 4 other angles that are equal to x. 4 other angles that are equal to x. So we can start by looking, because we can see that it's connected to a parallel line. That means it has an angle that it relates to on the other parallel line. So angle A1, that is 12.1, angle A1, using the parallel lines, it is equal to angle C2, that is x, and the reason is alternate angles. And state the parallel lines, AD is parallel to BC. Okay, so we're saying this is x. Now we know that if we have a tangent, we also check if this angle has any connection with the tangent. So we can see that the chord DP is the one that is subtending angle A1. And the angle that the chord DP makes with the tangent is angle P1. So using tan chord theorem, we are also saying angle A1 is equal to angle P1, which is x. Here we are using tan chord theorem. Chord DP continues to be, and then the tangent also continues to Q. So that means we have two lines that are crossing and that produces vertical opposite angles. So we are also saying angle P1 is vertically opposite to angle P5. So these are vertically opposite angles. And then we need one last angle. We have 1, 2, 3. We need another one. And then we'll also notice that angle A1 and angle E, they are angles in the same segment. So we are saying angle A1 is equal to angle E, which will be equal to x. These are angles in same segment. So those are the 4 angles that the first question required you to list. So basically it's all about application of theorems, trying to see the theorems from the given information and using the facts that we know, like on parallel lines and lines that cross. Then 12.2, show that angle EPA, which is P7, show that it is equal to x plus y. All right. So we know that angle EPA or angle P7 and angle D1, they are in the same segment. And this is the angle that is connecting to the parallel line. And now we should be so vigilant to check this angle. Does it relate to another angle this side? So we'll see that it does relate to angle BCR. So we are saying angle P7 is equal to angle D1, angles in same segment, and then angle D1 is equal to angle C. This one and this one are corresponding angles. So these are corresponding angles. Let's take the parallel lines. AD is parallel to BC. So therefore, since angle C is x plus y, therefore angle P7 is equal to x plus y. Then moving on to the last question, 12.3. Determine the numerical value of x plus y. Determine the numerical value of x plus y. If it is given that dCTP, is a cyclic quad. So now we are having a cyclic quad. So the examiner is trying to tell us that use the angle properties of a cyclic quad. So what do we notice now? How do we go about it? The last question we did was P7. That would mean that angle P3 is x plus y. So we can start from there. That's 12.3. Angle P3 is equal to P7, that is x plus y, vertically opposite angles. And then from there, we also know that we have a tangent that is RP and a tangent RC. So these tangents are equal, and that creates an isosceles triangle. So it means we are able to find the size of P2. P2 will be y. So we have to write that down. Angle P2 is equal to angle C1, which will be equal to y. These are angles opposite equal sides. And thereafter, now we need angle P1, and angle P1, we have already said angle P1 is equal to x because of the time chord theorem. So we are now saying the whole of angle TPD. Therefore, angle TPD will be equal to x plus y plus x plus y. X plus y plus x plus y. And that will give us 2x plus 2y. And then we know that if this is a side equal opposite angles, they add up to 180. So we are saying therefore 2x plus 2y plus angle C, which is x plus y, should give us 180. And the reason is opposite angles of cyclic equal. So that will be 3x plus 3y is equal to 180. And then we factor out 3 so that we can have our x plus y. And then we divide by 3. That is 180 divided by 3. That gives us 60 degrees. So we are saying the value of x plus y is 60 degrees. And then that's how you were supposed to go through. It gives you practice on so much integrated question, and you need to be so analytic. Otherwise, you miss and leave out the question. We hope that will not happen in your exams. All right. Let's meet on another question paper.